Let's practice using some of the properties of exponents. First, we have a product of powers here, and this is two powers multiplied with the same base. We add the exponents. This makes sense because if we wrote this out the long way, there'd be 8 x's multiplying by each other. Our second problem is a quotient of powers. We have 2 powers with the same base being divided. Here we get y to the 8th because 27 minus 19 is 8. This makes sense because if you listed these all out top and bottom, 19 would cross out with 19 on top, and you'd end up with 8 left on top. Next we have z to the 3rd to the 18th. This is a power to a power, and it'll be equal to z to the 54th. This makes sense because it'd be z to the 3rd times z to the 3rd times z to the 3rd times z to the 3rd 18 times, which means you'd have 18 3's that would add up to be 54. Next is a power of a product. The answer would be m to the 70th, n to the 21st, because the m to the 10th and the n to the 3rd are raised to the 7th, so power of a power you multiply, and it reaches both the 10 and the 3. Next we have another power of a product. This time there is a coefficient. Because of the parentheses, the 4th power goes to the 3. 3 to the 4th is 81, and 4 times 15 is 60. Next we have a power of a quotient. This becomes a to the 36 over b to the 60th, because the parentheses make the power go both to the a to the 3rd and to the b to the 5th, so we raise both powers to a power. Next we have z to the 25th to the 0th power, which equals 1 as long as z itself isn't 0. Anything to the 0th power is 1 except for 0 to the 0th. Last we have a negative exponent. Whenever we have a negative exponent, numerators go to the denominator and denominators go to the numerator. In this case, x to the negative 12th is already in the numerator, so it'll shoot down to the denominator and become a positive exponent.